Today we're going to add on to what we know about hydrocarbons by adding on groups other than hydrogen and carbon. These are called functional groups. These functional groups actually end up making the organic compound behave a little differently, and it'll look differently as well. And that's how we're going to identify the different functional groups, is by what they look like. You are going to be using Table R today, and Table R is awesome because you won't have to memorize any of this. You'll just have to know where to look. The first group we're going to talk about is the first one that's in Table R, the halides. You can see underneath, sometimes it's called a halocarbon. I don't like that word. I use halide, but just so you know, it could also be that. The functional group, or the thing attached to your hydrocarbon other than hydrogen and carbon, could be fluorine, chlorine, bromine, or iodine. And you'll see right next to each of them kind of a shorthand for what we're going to add to the name. It's fluoro, chloro, bromo, or iodo, depending on what's added. The next column gives us the general formula. R, and if you look way down at the bottom, it tells you R represents a bonded atom or group of atoms. It's the rest of the hydrocarbon. And X is the halide, so whatever halide, F, Cl, Br, or I, that's attached to it. So over here we have an example. They have used the condensed structural formula to show you what the example is, and then they give you the name. So you have to know how to expand the condensed structural formula in order to use that example. I'm going to have to go through each of these with you and show you where that name is coming from by expanding those out. But let's start with our first example here of halides. And halides have F, Br, Cl, or I attached, so a group 17 attached to it. So what we're looking at here, normally if you did not have that bromine, this would just be a 2-carbon hydrocarbon, which we would call, since it has a single bond, ethane. Since we have this bromine attached to it, we need to change the name a little bit to indicate that that's there. How we do that is, we would normally call this ethane, and we're just going to stick out front bromo, which you can get from right here to remind you what you're going to add. So it's bromoethane. And then you don't really need it this time, but I think it's always best to add it since you won't be wrong. Give an address for that bromine. It's 1-bromoethane. All right, let's look at the other one we have here. In this one, we have 2 fluorines attached to it, but let's first just look at what we would call this on its own. It would be ethane again, because it's a 2-carbon alkane. And then we need to add our fluoro. Since there are 2 fluoros on there, we're going to say difluoroethane. And then we need to give the address of both. This time you don't have a choice because they could both be on the first carbon. It could be 1,1-difluoroethane, but since it's on the second one and the first one, we're going to say 1,2-difluoroethane. Let's look just for a second at our example here, and I'm going to write this up at the top of the one in our reference table here, 2-chloropropane. When you expand out your condensed structural formula, you're going to take it 1 carbon at a time. The first carbon, you can see in our example, has 3 hydrogens. It's a terminal carbon, so you can assume 1 up, 1 down, and 1 to the left. And then it is bonded to a carbon that also has a hydrogen. But what's different here is you see that Cl, it's also bonded to a chlorine. And it wouldn't matter if you put that on the bottom or on the top, as long as it's on that second carbon. And then our third carbon, our last one, has 3 hydrogens like this. So when you see your example of the name, it says 2-chloropropane. it'll give you a clue how to do this. We have 1, 2, 3 carbons. That's where the propane came from because they're all also single bonded. And on this second carbon, there's a chlorine. Here's carbon number 2, and attached is a chlorine. So you can use that example to help recall how to name these. You don't have to memorize how to name these as long as you know how to use table R. Let's talk about alcohols. Alcohols have an OH attached to your hydrocarbon chain somewhere. Sometimes it's more than one, sometimes it's just the one. But you're always going to have an OH attached somewhere to your hydrocarbon chain. This one, we're going to name this one a little different than we named the halides, but you actually have the opportunity again to look at the example in table R. So this time I want to look at that example first. In the example they gave us, I'm going to expand it out. We have a carbon with 3 hydrogens, a carbon with 2 hydrogens, another carbon with 2 hydrogens, and an OH. And then when we look at the name, it says 1-propanol. So what they did was they changed the ending to OL instead of just E. And then they gave us the address of where that OH group was. Our first example here, we have just 1 carbon. We would normally name that methane. We're going to drop the E and add an OL. Theoretically, you could give the address. This one, you don't need it. All right, let's try this other one. We have 2 carbons. We would normally name this ethane. We're going to drop the E. Now, in this case, we have 2 OH groups. Just like when we had 2 or more double or triple bonds, we would say di before the ending. So we're going to do that again, ethanediol. And then this one, we want to give the address of both because they could both be on the same carbon. It's 1,2-ethanediol. And actually, that's antifreeze, in case you didn't know. Okay, we're going to move on to the next one. These are ethers. Ethers, when you look at table R, have carbons that are connected by an oxygen. Oxygen, if you recall, makes 2 bonds, so you would have a carbon on either side. The example we have in table R, let's see if I can move it out of the way but still keep it big enough to see. If you look at the example we have a carbon with 3 hydrogens, and then next to that we have an oxygen, which is then connected to a carbon with 2 hydrogens and a carbon, let me move this, with 3, like so. And when you look at the name they gave us methyl ethyl ether. What they do is they name the shortest side chain first. So this side chain or side branch is only 1 carbon long, so that's why they called it methyl. Then they named the longer side chain, which in this case was a 2 carbon, ethyl. And then because of the functional group, the oxygen in the middle, they tack on ether, methyl ethyl ether. So let's do the example we have here. We have a 1 carbon connected to another 1 carbon by an oxygen. That's how we know we have an ether, because it's right in the middle there. According to the example we had, you name your shorter chain, then your longer one, and then add ether. Well, these are both the same length, so you have a choice here. You can call this methyl ether, or you can call it dimethyl ether. So the most important thing is, of course, identifying first your functional group so that you can then use your table R to figure out how to name it. I'm going to move this out of the way. Now we have a 1 carbon chain on this side of the oxygen. The oxygen here, our functional group, is letting us know what functional group we're working with. It is the ethers. And then on the other side, we have a 3 carbon group. So we're going to name our shorter one first, methyl. And then 3 carbons is propyl. And then we tack on ether, methyl propyl ether. The next functional group we're going to talk about are the aldehydes. And the aldehydes are characterized by having a carbon with a double bonded oxygen. And then you'll notice you have a hydrogen here. And really, because carbon can only have 4 bonds, this has to be the very end of the chain. Hydrogen can't bond to anything else. It only makes 1. So when you look at your general formula, you could have any length of carbons after that. That's the rest of the chain. But on the terminal carbon, you need to have that double bonded oxygen. So here's our example here. I'm going to put this like this. So you remember that's the functional group. And the example we have, propanol, we have a carbon with 3 hydrogens connected to a carbon with 2 hydrogens, and then a carbon with a double bonded oxygen, and they actually drew in the H that's on the other side of this. And that really lets you know that's the end of our chain. And when they named it, they called it propanal, A-L, to remind us of the aldehydes. So propanal is the answer. So all they did was they counted the number of carbons, and they're all single bonded to each other. Propan, dropped the E on propane and added Al. You will never have an address with the aldehydes. Don't ever give an address. The point is that it is on the terminal carbon, whether it be number 1 or the very last one, and you never ever give an address. Essentially, if you don't have an address in the example you're given here, don't give an address in the name. Okay, these ones don't have addresses, don't give an address. Before I said, well, you can give an address whenever. That's true of the ones that have addresses here. It's true of the alkenes and alkynes, but it is not true for any of the ones that don't have an address in Table R. All right, let's look at our examples here. This is a 1 carbon aldehyde. That double bonded oxygen on the terminal carbon is telling me I have an aldehyde. 1 carbon, we would call that methane. So we're going to drop the E, and because of that double bonded oxygen on the terminal carbon, we're going to add Al. That's methanal. Our other example here, again, we have our double bonded oxygen on a terminal carbon. We count our carbons. We have 4. We would normally call that butane. We're going to drop the E and add Al, butanal. And those are the aldehydes. All right. Next ones we're going to talk about are the ketones. They, again, also have a double bonded oxygen, but what's distinct about these is if you look here in the general formula, you have the R here and the R here. That means that there are carbons going off in either direction. They can be any length. But this carbon with the double bonded oxygen is somewhere on an internal carbon. It can't be on the end, because if it was on the end, it'd be an aldehyde. So ketones have that C with the double bonded O, but there's more C's on either side. So I'm going to put R and R prime or whatever they have there. Okay. So let's look at the example they have. They gave us a carbon with 3 hydrogens. And then we have a carbon with a double bonded oxygen attached to a carbon with 2 hydrogens, attached to another carbon with 2 hydrogens, attached to another carbon with 3. and they called it 2.1-Functional. So what they did was they counted the number of carbons, which was 5. So we would call that pentane normally. So they dropped the E, add -one, like the ketones. Just like up here we added al, like aldehyde. This we're adding -one, like ketone. And then they gave the address of the double bonded oxygen, because that could be on the third. Can never be on the first, because then it would be an aldehyde. All right, let's see if we can apply this to a couple other examples. So we have a double bonded oxygen on an internal carbon. That chain is 3 carbons long, so normally we would call that propane. Because it has that internal double bonded oxygen, we're going to add the ONE, it's a ketone, and we're going to give that an address, 2. Let's try the next one. Here's our identifier that this is a ketone. It is 1, 2, 3, 4, 5, 6, 7 carbons long, which makes that heptane. But we drop the E and we add ONE, heptanone, and then we have to give the address. If we count it from this side, it'd be on number 5, but from this side, it's 3. So we're going to call that 3-heptanone. All right, our next example, organic acids. Organic acids have a C with a double bonded O and then an OH. And off of the C, you can have any length of carbons. So here's the example they gave us. Let me do my C double bond O, OH. Okay, and then I'll move this out of the way a little bit. So the example they gave us, we have carbon with 3 hydrogens, like so, bonded to a carbon with 2 hydrogens, bonded to a carbon with a double bonded O and an OH. And now when we look at the name, they're calling it propanoic acid. So this has 3 carbons just like propane, except we dropped the E and added oic acid. Notice it does not have an address, and it can't, because this carbon, in order to have the double bonded oxygen and the OH attached to it, must be terminal. So do not give an address. Let's look at our examples here. I have 2 carbon chain, and I can see I have an organic acid because of the C with a double bonded O and the OH on it. So we're going to name it based on the number of carbons. It's 2. So we would call this ethane, except we drop the E and add oic acid. Ethanoic acid. Actually, that's the acid in vinegar. Sometimes it's called acetic acid. All right, let's look at the next one. Once again, I have my C double bond O, OH, so I know I have an organic acid. I count my number of carbons, 1, 2, 3, 4, 5. So we would call that pentane, but we're going to drop the E and add oic acid, just like the example from our notes. All right, we have just 3 more to go. I hope you're seeing that if you can just use Table R, it'll really help you in order to name these without having to memorize anything. So let's look at Table R for esters. Esters are 3 up from the bottom, and they have a carbon with a double bonded oxygen attached to another oxygen, and then on either side of that would be more carbons. And that prime, that's just some other length of carbons. They don't have to be the same length of carbons. So let's look at the example they gave us here. If you look, it says we have a carbon with 3 hydrogens, 1, 2, 3. And then the next carbon has 2. 1, 2. And then the next one has a carbon with a double bonded oxygen. And then another oxygen. And then a carbon with 3 hydrogens, like so. And then when you look at the name they gave you, it says methyl propanoate. Methyl means 1 carbon, and propane means 3 carbons. So let's kind of dissect what they've done here. We have our functional group right here. So there is a chain that contains the functional group in it. And then we have this other thing. This other thing is a branch, which when you look at the name they gave us, they named a 1 carbon branch, methyl. So the side that doesn't have the functional group, we're going to name like it's a branch, methyl. And then the other side, they called that propanoate. The other side, we count our carbons, 1, 2, 3. We would name that propane, except we're going to drop the E and add O8. So essentially, the side that gets the O8 is the side that has the functional group, that has the O's. So let's do 2 more examples and see if that'll make a little more sense. First, let's identify our functional group. Here it is. That is the side that's going to get the O8. So let's first name our branch. We have a 2 carbon branch. That would be eth, and then YL for the branch. And then the side that has the functional group is also 2 carbons, so we're going to call that ethane, except we're going to drop the E and add O8. Let's identify our functional group. So that's the side that's going to have the O8 in the name. So let's count our carbons on the branch side. 1, 2, 3. So that would be prop. And then the YL, because it's a branch. And then let's count the side that has the O's. That would be 4 carbons. That would be butane, except we're going to drop the E and add O8. All right, those are probably the hardest ones to name. On to our amines. Amines have a nitrogen, and nitrogen, if you recall, has 5 valence electrons, so it'll have a pair and then 3 singles, so that's why it can make 3 bonds. In fact, those 3 bonds can be connected to up to 3 carbon chains. So we're going to have a nitrogen, and then you could have carbons off of 3 sides of that. So we have to know how to name that. So let's look at the example they gave us. We have a carbon with 3 hydrogens. I'm just looking here. And then next we have a carbon with 2 hydrogens. And then another carbon with 2 hydrogens, which is connected to a nitrogen with 2 hydrogens, like so. And then when you look at the name, it says 1-propanamine. So that prop part, or propane part, comes from the fact that we have 3 carbons. So that's the propane. Drop the E, add amine. Okay, and then it says it's 1-propanamine. So let me show you what 2-propanamine would look like so you know what I mean. So when we have 1-propanamine, the number 1 carbon is attached to the amine group. Here, it's the number 2 carbon that's attached to the amine group. So this would be 2-propanamine. Running out of room here. Okay, so let's look at our first example. We have a nitrogen, so we have an amine. In this case, the nitrogen has 2 chains. So when we go to name this, so this is going to be a branch. The shorter one is always a branch, and then the longer one is going to get that amine part of the name. So we have a 1-carbon branch, so that'll be methyl. And then on this side we have 3 carbons, so that would be propane, except we're going to drop the E and add amine, methyl propanamine. And then in the example we had a number, so we have to give a number to where that nitrogen is attached to that propane chain, and it is attached to the number 1 carbon, so we're going to wedge that in there. I've never seen them do that to a student on the exam, but just so you know how you would do that. All right, next one, we have, once again, an amine group. This time, though, it only has 1 chain, and it is 4 carbons long, so that would be butanamine. And then it is on the first carbon, so it's 1-butanamine. Last ones, we have amides or amides. I don't care how you say it, either way. With an amide, you have a carbon with a double bonded oxygen, which is also bonded to a nitrogen. So, and keep in mind that nitrogen can have up to 2 chains on it, and the carbon could have more carbons after that. So it can get kind of complicated. Let's look at the example we have in table R. We have C with 3 hydrogens attached to a C with 2 hydrogens, which is attached to a C with a double bonded oxygen, which is attached to a nitrogen with 2 hydrogens on it. So this is telling us we have an amide or amide, however you want to say it. And when you look at the name they gave us, they called it propanamide, and they did that because of the 3 carbons. And that carbon that's also attached to the nitrogen has that double bonded oxygen. So we have 3 carbons. We would normally call that propane. We drop the E, and because of that C double bond O with a nitrogen, we're going to add amide, propanamide. So let's look at our example here. We have that C double bond O with a nitrogen, so I know I have an amide. It is 1, 2, 3 carbons long, so I would normally call that propane. I'm going to drop the E and add amide. Hey, that's the same as the one from table R. Let's do a different one. We have our C double bond O attached to the nitrogen, so it's an amide. We're going to count our carbons, 1, 2, 3, 4, 5, which would be pentane. So we name pentane, drop the E, add amide. And that's all there is to it.